Good afternoon, everyone. This is Chris Riley with System Source. Thanks so much for joining Dave, Ferg, and I today for today's webinar on securing your Microsoft Azure infrastructure. This is one kind of a series of presentations on Azure security, looking at it from several different directions, and Dave will probably talk a little bit more about that as we go. So we want to welcome you to this session as we continue to look for how to really secure that new modern data center, which is in the cloud. So a little bit on the agenda. I'll do a few introductory remarks here, and then Dave will jump in, taking a look at some of the Azure Virtual Network options, look at the best practices for those, look at segmentation, as well as just kind of service and private endpoints. We'll look at securing administrative access with Microsoft's role-based access control, and then finally we'll look at monitoring with Defender for Cloud. And then we will do Q&A at the end, so just you can send your questions to me at any point. I'll talk more about that in just one moment. So hopefully, if you've asked for a pizza when you register, you have that pizza in front of you. But if the pizza isn't there quite yet, just note Julie Dellinger's email address on the screen, and you can always reach out to her, and she'll do her best to try to solve the pizza conundrum. All right, just a little bit of housekeeping. So during the webinar today, the audio is in presentation mode, so you can hear us, but sadly we can't hear you. But we do that so that any background noise, music on hold, those types of things that might be where participants don't come through to the whole group. But you can reach me at any point. I'll be monitoring the chat all the way through the session today, so you can reach me through there. And also questions, I mentioned the Q&A. Q&A will be at the end, but you can just jot your questions at any point right into the questions tab, and then I'll read those out to Dave at the end. And if we don't have enough time for all questions, it also gives us an opportunity. We can just research those and get back to you after the session, so we make sure that you get the educational benefit that you signed up for today. This presentation will be sent out to you in a PDF format later on today, as well as a link to the recording, so that you'll have both resources for you today. Don't have to write furiously. And finally, there is an evaluation that you'll receive after today's session. If you can take just a moment to complete that. It lets us know how we did, but more importantly, it lets us know how we can do better in the future. And it also gives you an opportunity to let us know what additional resources that you may need to kind of do your job better. And so there'll be several options there, or just jot in what you need, and we'll try to provide those resources to you. And we do try to make it a little bit more fun, but we'll pick those completed registrations, or completed evaluations rather, and we'll pull from that. So one lucky person will get a $50 Amazon gift card, the gift that always fits. Okay, just a little bit about System Source briefly. So we do have mostly System Source friends here, so not a lot of new folks on today's session. So I'll go briefly through this, but just to level set. So we've been around since 1981, and there's about 70 of us at System Source. And we work with IT professionals from South Central Pennsylvania all the way through Maryland and down into the DC metro area. So a lot of folks come to us when they need to acquire new technology, whether that's going to be in user computing technology, or most of the work that we do is in the cloud. So or the modern data center, whether that's the on-prem version of that, the traditional, or the modern version of that, which is the cloud. So on the on-prem version, we're going to be looking at things like compute and storage and security and virtualization, the whole Microsoft stack, VMware, looking at security like Arctic Wolf, Barracuda, networking gear like from Cisco Meraki, HPE Aruba, HPE for servers, and for storage. All of those types of things happen in that modern data center, whether it's in the on-prem piece or whether it's in kind of the analogous one, because you still need all those same types of things: storage, servers, virtualization, etc., in the cloud. So we do design, implementation, support, and troubleshooting for all of those kind of data center technologies. People acquire because they need to improve. So we talked a little bit about consulting in cloud. In addition to Azure, we also do work in Amazon Web Services, as well as wherever clients want to put their resources. So it could be in colo centers, it could be in our data center, other data centers that they control. So regardless of where the resources are, and many of our clients have resources in all of those locations, then we can help kind of manage design support in all those. We also have training for probably about 3 dozen different technologies or manufacturers, including all the whole Microsoft stack under our training area there. There will be a little bit of information on that later. And present for professional AV, so all the Teams rooms, Zoom rooms, WebEx rooms, so all the large monitors, speaker systems, microphones, etc., that make those systems work. That's all in our presentation systems group. And finally, maintain, where we do it on either a you call us when you need us basis under service and support, whether that's during the business hours or after business hours. So after business hours, just follow the voice prompts on our phone, and managed services, where we are the IT department for dozens of organizations in this region. So that's a little bit about System Source. We do have a number of upcoming webinars, which you can see on here. So on the 13th, for kind of daily practices to secure IT. So what are the things that need to be done regularly to make sure that IT stays secure, instead of just point-in-time sorts of things? We'll look at that on the 13th. Looking at Power BI on the 14th, and then on the 15th, there's a pickleball and free sunglass, kind of an open house. That's up at Dill Dinkers in Cockeysville. So if you'd like to, if you're a pickleball player or just want to try it out, first time, most of the folks are first timers, please register for that. And then finally on the 21st, we have the proactive steps for kind of making sure that your cyber insurance claims are paid if you have one, and then also how do you minimize premiums. And kind of a twist on that, we're going to look at what if you've had a claim? What happens after that? So we'll be taking a look at those topics on the 21st. With that, let me go ahead and hand the reins over to Dave, please.
Thank you, Chris, and thank you all for joining us this afternoon. I hope what we're going to present this afternoon has some value to you. It's another in a series that we're doing on security related with Azure. Last month we did something on identity security. Today we're doing infrastructure security. Next month we're going to be doing storage security, and in July we're going to go revisit identity security, covering things we were not able to cover in the first piece. It will focus a little bit more on business to business, business to customer, remote access types of securities. So in addition to all those other webinars we're doing, this is just a series of Azure security, and I'm just kind of giving you a heads up of what's coming there. So let's dive into infrastructure security. So in this particular webinar, I know Chris read off a general agenda. We're going to break this into 2 segments. I'm going to really talk about, at first, traffic management and security. In other words, virtual networks and subnets, VNet peering, network security groups, gateways, firewalls, those types of things. And we're going to get in a little technical here, and how they work, what they do, what the different versions, whether it's standard or premium, what they can do differently, and how we can secure the infrastructure itself. And then we're going to deal with management security. How do you know you're secure? Are we securing administrative access with role-based access control? Are we getting insight into our devices, our networks, our routing, where our security may be lacking through tools like Defender for Cloud? And also Azure Monitor, where you can collate your logs from various sources and pull them together to make dashboards and reports and things like that, so you can keep track of. If you don't keep track of what's happening, if you don't have alerts, if you don't have logs, you don't know where you stand with the security. So that's an important portion of this. First is, setting the security. That's what we're going to talk about first. And second portion of this is then, how do you know you are really secure? What is Microsoft's recommendations to enhance your security if they would be feasible for you or not? So that's what we're going to talk today about. So let's start with the traffic management, network security pieces. So everything in the Azure platform world, because we're talking in the infrastructure as a service world, if you have virtual machines and other resources like that, you're going to have virtual networks and subnets. This is where your IP addresses are built, and subnets can break that down. Understanding that traffic between the subnets within a virtual network communicate without any necessity. You don't need to build the routers to know how to get from point A to point B. So you have open communication immediately. As you build other virtual networks, whether in the same subscription or even in a separate subscription, there isn't necessarily traffic communicating between them immediately. But we have ways of opening up this communication between various subnets that you may separate for administrative reasons, for security reasons, for any number of reasons as to why you would want to create another virtual network. And I maybe should explain, a virtual network is the address space in which you want to work. The subnets are then how you divide that up within the address space. So one way we get these things to start communicating to each other is we could do VNet peering. What that does is opens this communication up for just transparent communication between VNet 1 and VNet 2. So you don't have to worry about routing. That's going to be taken care of internally by Microsoft. Or if we want to be more specific, we can build a route table from subnet 1 and subnet 2 to reach a specific device or a specific subnet or some target location. So the route tables are more specific. The VNet peers are going to be just general connections between multiple VNets. And they're going to be very handy for certain configurations, as we'll see in a minute. So now that we got traffic flowing between the two, we would use network security groups to control what traffic is actually allowed into or out of the subnet or the device itself. Network security groups are access lists. They can be applied to a subnet, as you can kind of see in this diagram here. It's kind of representing there's one of them attached to a subnet. You can even attach them to devices themselves, so you can have multiple layers of network security groups, and we'll drive into that a little bit more in a bit here. If you want to do remote access into your world, all of your Azure devices have a public IP address, or I should say can have a public IP address associated with it that you can access right over the internet in a secured fashion. It's TLS, but the access is directly over the internet. Or we can focus our remote access to a hub virtual network. This is considered a best practice to build a hub and spoke, where you allow your external access to come in from one place, and then from there you control it out to the various subnets. So I would gain access, for instance, through a VPN device, and can then route up to other subnets as I build connectivity. This virtual hub would be the place where you would put like VPN gateways, the firewall, bastion hosts that are used for RDS management, RDP connections to your servers for management. Each of these require their own subnets because these types of devices, the VPN gateway, the firewall, the hosts, these are actually clusters of machines that are going to be on a subnet that support the service that you're using it for. You connect them out to your spokes through VNet peering. That's a typical design for security, where we're bringing all of our external access into from one place and then letting it go through the Azure infrastructure from there. This is a way for us to be able to remove public IP addresses from our devices if we want, or just build the NSGs on those public IP addresses to block things that we don't want. All right, so route tables and security groups. Let's dive into those a little bit. So let's take a look at the route tables. These are devices that or services that link subnets with defined routes. So for instance, if I want to go to the subnet 172.20, which is a virtual appliance, my next hop is 172.120, and it tells me how to get there. That's what a route table is. It's going to allow you to control the path or through what devices traffic needs to go to get to wherever destination you want to get to. For instance, I'm on an Azure subnet. I want to get to something that's on premises. My next hop is the VPN gateway device, which knows how to get down to my on premises. We would use a route statement for something like that. This is where you would define the name of the route, what type of device you're connecting to. That's would look like what the next hop would be. Am I connecting to a gateway, to a network, to the internet? What am I connecting to? And then the next hop. It's a pretty simple concept, but necessary for controlling how traffic flows in your network. It's an oft overlooked configuration, feature available to you, because this is all going to, again, allow you to how things are going to connect, not just broadly over VNet peering, but I'm going to control the path that it's going down. Network security groups filter traffic. You want to be thinking along the lines of access control list if you're familiar with those. These can be applied, as I mentioned earlier, to subnets, as kind of shown in this diagram here, or to network interface cards. And they will work together as a double filter to get into a device. For example, I want to connect to VM1 coming from, let's say, the internet in this diagram. I first have to go through NSG1. And if my traffic is allowed through NSG1, there's an NSG2 that would further filter down the traffic that's relevant to just VM1 here. VM2, on the other hand, would only filter through the subnets network security group and then go right into VM2. So I didn't do any additional filtering. So you would keep it most generic up at the subnet. You would get more resource specific on the network interface card. Clearly, if it's blocked by NSG1, NSG2 never gets it. Over in this example here for VM3, there is no subnet, so only NSG2 is my security block to allow what's in and what's out. And VM4 has no filter, so if it's getting in, it's getting into my device directly. So these can be linked to subnets, like I've mentioned. They can be linked to NICs, like I've mentioned. And when you go to configure the filters, it's following the 5-tuple rule. What's the source address and source port? What's the destination address and destination port? And what protocol? In the route table, NSG configuration, this is where you can configure inbound rules, outbound rules, network interfaces to which it is linked, or subnets to which it is linked. They all come with 3 default rules that allow internal connectivity to the device. So all internal connectivity is allowed, with anything else being a deny at the end of that. From there, we add more rules that have a higher priority and will be processed first. So for instance, I'm going to add a rule. From where is it coming from? Is it any, which means it's coming from any place, or is it coming from a specific subnet or a specific port? Where is it going to? Is it going anywhere, or is it going to a specific subnet, or is it going to a specific device? What service? Think HTTP, RDP, things like that. What port ranges it's going to be used, what protocols we're going to use, and then are we going to allow or deny that? And then you set a priority. So this is showing priority 100. This will sit up above the defaults and be processed first before it falls through to the lower priority devices. As you're building your rules, pay attention to the priority, because if a higher priority is blocking something that you need, the lower priority rule won't allow it to pass. So just keep in mind that order. Much like any access control list, this is no different in how you're controlling that. All right. So let's get back to this diagram right here. Let's talk now about the Bastion host. We're going to dive into a little bit about what these 3 are now. The Bastion host is what's going to protect your RDS, or RDP protocol connections into your servers. If you've created an Azure VM before, you know that you can open up RDP to the internet. And if you did that, by the way, let me step back a minute. If you did that, by the way, you would see a rule in the network security group for port 3389. That's, if you would say, yes, I want to allow it in, you'll see that rule in your environment here. All right, so let's get back to where I was here. The Bastion host, though, allows you to eliminate that public IP address with RDP connectivity to it. And you now connect to the Bastion host over 443. Bastion host then will make your RDP connection to whatever the resource is. So in this diagram here, if I wanted to connect to VM01 sitting up here in subnet 1, I would make my connection to the Bastion host. Bastion host is able to get to VM01 because there's a VNet peer that lets me to get up to that virtual network and thus into that subnet. So I have a secure connection here for RDP to manage my devices here. Now this is a for-fee service because you're putting resources on a subnet, but it does secure your devices because you really don't want RDP open to the internet on your devices. Even if you secure it to a specific source address, it is better to use a bastion host than have even a restricted RDP directly to the server. So consider that in your environment. All right, so there's the bastion host. I'm kind of walking ahead of myself. All right, VPN gateway, that's another device that you would put in a hub because this is an external connectivity that comes into your world. It will allow site-to-site and point-to-site connectivity. They come in various models, various SKUs, if you will, from basic to the VPN GW1, 2, 3, 4, and 5. You can look over here at the specs, and then again, when you get a copy of this, you can see them a little more clear, what the bandwidth limitations are, what the site-to-site tunnel limitations are, what the point-to-site limitations are, etc. They also have available zone redundant SKUs. These would have the same specs, except they have an AZ at the end, meaning that it is spread across multiple data centers. I don't have a slide on this. I've done this in many other webinars, so if you've attended before, you've seen this slide. In a region is made up of data centers. Each data center is an availability zone. So your VPN gateway could be spread across 2 data centers or 3 data centers, however fault tolerant you want that to be. That is an AZ model of these things. It's the same VPN configurations. It's just how fault tolerance is this device. So if this is a critical communication point to your business, you really want to be thinking along the AZ models when you're doing that. So you can put it in multiple data centers and at least get some data center level protection. Okay. When it goes to make a site-to-site connection, it's going to connect to your firewall on premises. And you can check, and this is the URL you would go to, right here, where you will get a list of what Microsoft has tested, has proven to be what they haven't tested, what they've proven to be compatible, what is not supported, what is supported, etc. If your device is not on that list, that does not mean you can't make a connection to it. It just means there won't be documentation for it, and it wouldn't be supported if you needed to call for support. But I've connected these things to devices that are not on this list, provided they're following basic IKE protocols and things like that. You generally won't have a problem, but I would still suggest that you look on this list to see if your firewall is on here, because then you know you're going to be able to get some support. So in the configuration, there's a couple things you need to do. One would be clearly what SKU am I going to deploy? So this is the virtual gateway that you're going to be deploying here, and you'll figure out what SKU you're going to be putting onto that. Another thing, which we'll get to on a future slide, is you're going to configure a local network gateway, and all that is an Azure resource that defines what your on-premises world looks like. What is its public IP address? What internal subnets are located in that area, so it knows how to route. And then you're going to build a connection that will use this VPN device that we're deploying, and we'll use the local network gateway information to make a connection to your device. So we're going to deploy the gateway itself. We first pick the SKU that we want. If I had picked an AZ SKU in this picture here, I would have seen availability zone information to choose. What public IP address do you want to be assigned to this VPN device, because it needs public IP address for configurations? And what kind of configuration? Are we doing a standalone? Are we going to be doing active mode, which means you'll have 2 of these running so that if one ever went down, the other one's up and running. That does require the BGP protocol, so your on-prem firewall needs to support BGP, and you can do an active configuration. The local network gateway, again, is just a resource that defines what's on premises for you. As in any resource, what subscription am I putting it in, what resource group I'm putting it in, and now clearly a name. what is the public IP address of your on-premises world? And what are the internal subnets? So that will tell the VPN gateway what your device looks like. So any traffic trying to go to 10.0.0 or 192.168, as shown in this example, the VPN router will know to send it to address 123.123.123.123, and then your firewall can take it up from there and do the routing. Right? Then you make a connection. So when you make a connection, you're going to give it a name, and it's going to use that network, local network group or gateway for defining what that endpoint is. So that's what a connection is. What gateway are you building it on? What is the local network gateway? This one says site 1. That would have said site 1 here, if you'd have looked at that there. Is there a pre-shared key for that connection? What protocols are we going to use? Are we going to use a default IPsec policy, or we want to hit custom? And if you hit custom, you have this, have the settings that you can configure. What is phase 1? What is phase 2? What is lifetime? And you can configure that to match what your on-premises world is, so they will handshake and make the connections. So that's the VPN gateway. That's the site, and I walked you through the site to site. There's also point to site, which I've covered in other webinars. This is your end user making a connection in for access to resources on that. So that, again, I just walked through the site to site in this example here. So let's talk about firewalls, because that's the other one you would put into a hub virtual network. The Azure firewall comes in 3 models: basic, which almost no one uses, standard, and premium. And there's several features in each one. I'm going to drive through them in a little bit here. You can see it on this chart. I'll leave the chart here. We'll drive in detail a little bit more. But clearly, as in all things, the more you go up in price, the more you get into features. And we'll talk about that in a minute here. So your standard SKU supports these features here and a few more. All right. Built-in HA. Remember, it's on a subnet. So that subnet is actually a cluster of devices that are on there supporting this. So it has built-in HA. It has Microsoft's threat intelligence. So not only does it have your configuration policies, it has Microsoft's built-in threat intelligence capabilities built in as well. So malicious IPs and fully qualified domain names, et cetera, like that, will be filtered out for you on that. It has a 30 gigabit per second throughput, and you can read down this list for yourself. It does network address translations, can support multiple public IP addresses, et cetera, and some form of web categories. When we talk about premium, you'll see a little bit more, but by web categories, this would be, if I was going to www.google.com, it would be categorized as a search engine. But that's as far as it's going to go with the standard. It's not going to, if you had a www.google.com/something else, and then continues on from there, the standard doesn't look that far down the URL to see what it is. The premium is everything that's in the standard plus these other things. And we're going to drive through with some of these in a little bit here, so in detail. TLS inspection. So it's able to get into TLS encrypted traffic and inspect it. Intrusion protection is built in on that. Full URL filtering. So now we're looking to the right of the .com and all those slashes and being able to filter farther down the line so that we're maybe only allowing access to a certain page on your website. And then full web categories on that. So it has, for instance, www.google.com/news is not categorized as a search engine. It's categorized as a news site now because it's looking to the right of the slash. So that's what the premium offers you. And so let's talk about a few of those features. So TLS inspection. In order to look inside of an encrypted traffic, it's going to have to decrypt it to look and then re-encrypt it and sending it on its way. So what it's going to do is it's going to require you to have an enterprise CA in your environment. And there, from the enterprise CA, you're going to generate a subordinate CA certificate and assign it to the Azure firewall, storing it in an Azure key vault so the firewall would have access to it. What the firewall then does is it proxies the destination certificate for the user. So in this example, user wants to go to contoso.com. So it starts to make a connection to contoso.com. This firewall then sends a certificate back for contoso.com so that my device now will form a secure connection between me and the firewall. The firewall can then decrypt that, check the traffic, and then make the connection out to contoso.com for me, encrypting that traffic. So we have encryption on the client to firewall side and encryption on the firewall to destination side. And it does that because this subordinate certificate here is able to generate the destination certificate so that the client thinks it's making its connection and still allowing the device to decrypt this and check it out and send it on its way. That's a premium feature. So traffic is encrypted between client and firewall and between firewall and destination. It is used for outbound connections. If you're trying to do this on the inbound connection, you're going to use the app gateway feature. Now, I'm not covering that in this webinar, what the app gateway is, but that's going to allow us to, quote unquote, break the TLS connection, inspect, and re-encrypt as it comes into your device. So if you are hosting something in your world and you want to inspect traffic coming in, that's the app gateway. If it's going out to your device, outside of your world, the Azure firewall will do that work for you. Intrusion protection systems. It compares traffic against an extensive database of known attack signatures. So this is what Microsoft offers you. It's going to do packet inspection, signature matching, and alert generations and blocking. So it will detect when an intrusion attempt is happening and block that traffic. So a lot of firewalls have this feature now. The Azure firewall has it in its premium as well. All right. URL filtering. This is going to be allowing you to filter all the way out to the right of the .com or whatever the extension is. So whatever website.com /A/B, I can build filters on saying anything trying to go to B, I'm going to allow. Anything going to anything else along the way, just website or /A, would fail. So now I can control what access I'm allowing. I'm not allowing access to a whole site. I'm allowing access to a portion of a site. So my users are not only getting to where they need to go for business and not getting sidetracked into other locations and other data. So this is going to give you a little bit more control over website access. Web categories, as I mentioned earlier, it's even using the examples I used. Your standard would look at the www.google.com, and that's as far as it would go with web categories. So it would be categorized as a search engine. Even if I typed www.google.com/news, the standard would recognize it as a search engine. The premium would recognize it as a news site because it's looking to the right out here. So those are features of the premium. So rules processing in a firewall. I'm going to run through this relatively quick, but I want you to get an idea of how the Azure firewall processes its rules. Clearly, you have rules that you want to be blocking. They can either be a network rule or an application rule. These rules can be pulled together into collections. Now, collections only handle rules of the same type. So I have a network rule collection or a application rule connection. And then these rule collections can be pulled up into a group. Each one of these have a priority. So rules are given a priority, collections are given a priority, rule collection groups are given a priority, and it will process them in this downward fashion. If you look at the diagram, it's going to look at the priority of the connection group, then the collections, then the rules, first processing network rules, then processing application rules. And that's how it works its way down. So Microsoft's built-in threat intelligence works. Then it processes all network rules, all application rules, and any infrastructure rules, and it finally finishes out at a catch-all. So let's take a look at this example to kind of give you an idea. All right, so we have a network collection group, and then we have rules in here, okay? So RCG1 has a priority of 100, RCG2 has a priority of 300, RCG3 has a priority of 200. Now, I want to process network rules first. So I'm going to first look for the lowest priority group that has a network rule in it, and that would be RCG3, and then I would process the network rule. Now I could look for more network rules. Well, that would be the next priority, which is 2, and there's a network rule, and it will process that. Now I'm done processing all network rules. I can start processing application rules. This group has the lowest priority, and then it has an application rule, so that's next. Then RCG3, which has the 200, has an application rule, so that processes here. And then RCG2 has that priority, and then it processes here. So it's by groups, collection, rules, each has its priority. If in this example, and I don't have it here, if one of these rules here, if there were multiple network rules, let's say in this RCG3, once I was processing the RG3 section here, it would prioritize those rules within that group right there as well. So there would be network rule with a priority of 300, then one with 350, et cetera, et cetera. And then it would move on to the next group. So that's how it processes its rules. The rule processing, the policies that you apply are free to putting against a firewall, unless you are applying these to multiple firewalls. So if you're using Firewall Manager to create a policy, the policies are free until you apply it to the second firewall. So, but you're going to want to, if you have multiple firewalls in your environment, maybe that are kind of mirroring each other from different locations, you have an East Coast, West Coast, and you want the same rules, you would use Firewall Manager. You would create the policies in one place. You would manage them in one place. So it's only one policy, and you don't have to worry about did I mirror it in the other location. It's one policy that you just apply to 2 firewalls. And at that point, you start paying for the policies to come in. All right, so now where are we going? So here we're back to this diagram, and we've talked about moving between VNets and things like that, and subnets and external access. But now what if you want to connect to a service, let's say storage in this case here. Storage accesses through a public IP address, but I don't want to access through a public IP address. I want to access it internally. Well, the one way to do that is to create a private endpoint, which is a network interface card that I'm going to assign to a subnet. And then that would let me connect that private endpoint to my storage, eliminating the public IP address, so that the only way I get access to this this storage is from an internal connection. I have to come through the VPN, for example, up the VNet peering into the subnet, and that's how I get my storage. I don't get it through the public IP address anymore. So that's a private endpoint. So let's drill into this a little bit more. So by default, Azure assigns public IP addresses to resources. So everything gets a public IP address, as you see there. What we want to do is get rid of that public IP address and restrict it to private IP addresses. And that's where, using the private link service, that's the service that connects this NIC to this resource. And that's private endpoints. And that allows you to get to a platform as a service device here, like storage, et cetera. As of today, or as of October 2023, and I should probably check to see if this is updated, these are the private endpoints are supportable. And I hit page 10, there it goes. All right, so I'm going to kind of move through this rather quickly here. This is the next couple slides here are just how they get configured, the basics of what name, what network interface, what region you're going to attach it to, what resource you're going to attach it to. This is the private endpoint. What virtual network and subnet do you want to put this private endpoint on, and how are you going to handle DNS? Now, the DNS is an interesting thing because your DNS is looking for the public name, but now you're only assigning a private IP address to it. So how does Microsoft deal with that? Well, it does that through private link DNS entries. So let's walk through what happens now. When I create a private link, it's going to create, first of all, it's going to take this first record, the public one that I'm trying to get to, and it will make it a CNAME, and then it will point it to an entry in the private link.database.windows.net zone. All right, so we're using Microsoft's public DNS world here. It's going to point it through here. So when I go to enter this name, I'm going to get directed over here and be given a private IP address. So I make a database query. All right, you can see like number 1 here. I get an authoritative response, and that will be the CNAME that directs me to the private link. So now I'm directed to the private link, and I get my private IP address, 10.5.0.5. That's what I've been given, and now I make an access over to the database. So I haven't changed how I access the server. I just now get directed over to the private IP address through this private link database zone, which is an editable zone. You can go in there and modify the zone manually if you needed to do some things. All right, so that's how that works. I put a private IP address on it. So you can do this to public devices now, let's say your storage, and users will still access it through the same fully qualified domain name as they do today. They'll just be getting it through a private IP address, keeping it in the internal world. Service endpoints are very similar to private endpoints in that they keep the traffic on the Microsoft network. The difference is they continue to use the public IP address to make that connection, but it routes over the Microsoft backbone. So I'm making a connection to a service using its public IP and its public name, but it's never leaving Microsoft's world because I'm connecting to it through a service endpoint. All right, it's looking at this virtual network service endpoint as its next hop, which keeps it on the that's what, when you create a service endpoint, that's what it's going to create here, and that's what's going to keep it on the Microsoft backbone and never hit the public network. All right. As you can see here, if I'm trying to make a connection, my next hop is this virtual network service endpoint. That's how you know a service endpoint has been applied to it. And that entry right there is what keeps that public IP address internal to Microsoft. These are the services that are supported for those. So which do you use? The basic difference is if all you want to do is secure traffic by keeping it internal, the service endpoint is fine. You don't necessarily need a private IP address. But if your Azure world is accessed from an on-prem world across a VPN gateway or across some globally peered connection that's bringing it into your world, you're going to want a private endpoint, because when it crosses that global peering or comes up the VPN gateway, that virtual network hop isn't available to you. So we need to switch it over to a true private address. So that's this little chart here that you'll get when you take a look at the slideshow will tell you, you can look at it then to figure out, do I want to use a service endpoint or a private endpoint? Bottom line, either one of those keeps your traffic internal to your world and doesn't get it out to the outside world. So now let's talk a little bit about management security. Starting with role-based access control. Now I've had this slide in many webinars, and one of the reasons I do is I don't see it implemented much. So, so I keep putting it out there because it's something you want to consider. We always want to work with the least privileged mindset. Yes, you can make it work by granting someone access, calling them an owner, and lo and behold, it works. But they have a whole lot more rights and capabilities now than you might want them to have. It's quick and easy. It's like making everybody an administrator of their desktop. They can do what they need to do and won't get blocked by security. All right, so role-based access control. In this diagram here, we're looking at a resource group resource. So we're looking at the access control, and this is where you would define who has access and what level of permissions they have on that. So when you go to assign roles to somebody for what they need to do, you can handle this by one of two ways. You can either do job function roles or privileged roles. Your job function roles are things like roles that pertain to compute resources, roles that pertain to storage resources, roles that pertain to networking resources. They're job function related. If I gave someone contributor role at a resource group, contributor role being a privileged administrator role, they have contributor to every resource in that resource group. If I gave them storage roles at the resource group, they only have permissions over storage objects in that resource group. So now I can give them reader, contributor, owner, whatever level of control permissions I want, and control onto what devices we're going to give these roles without having to go to each device and set a role-based access control. I can do this and let it filter down. Privileged administrative roles would be your owner, contributor, user access administrator, those kinds of things that would apply to everything and within the scope of where this is being applied. All right. You can always view what access people have. You can check accesses. And of course, like I said, you've granted somebody some level of permission, contributor, for example. It depends on what scope you've granted it to. Did you grant it all the way up at the management group, which is like everything at a subscription? So they would have everything within a subscription, at a resource group, which would be everything in the resource group, or down at the resource itself. So that's the scope. That's how far they can, that's the range, the realm of which they can gain permissions. So the permissions would be based off of who you're granting permissions, what permissions you're granting, to what scope, and then that is my role assignment. You want to be thinking least privileged access. Figure out what they absolutely need. Very few need owner, which owner, by the way, can grant other permissions. So contributor may be as high as you might want to go for any other user besides an IT staff that's going to need to manage ownerships. And then you worry about what scope you're granting that. You just don't come to the top and say contributor unless that's really what you want to do. Try to get as far down that scope as you can get, and you will secure your environment. If you wanted more information about how to manage that, I put that link in there for you. All right, so Defender for Cloud is another management tool. Now there's both a free version and a for-fee version of this, and they'll give you different, as you would expect, different levels of access. This is a service offered by Microsoft up in Azure. This is their bullet points. You can read them as you want, but it, comprehensive. It has machine learning. It's cloud native, et cetera, et cetera, et cetera. I'll let you read that on your own. It comes in two versions, like I mentioned. There's a free version, and then there's a workload protection, which is you pay per plan. So I can get protections for VMs. I can get protections for storage. I can get protections for some types of resource, and I will get more information about that resource now. Whereas the free will give me a general overall indication of what my security looks like. The for-fee will tell me about my specific types of resources, because it's now going to drill in more and get more information out of the logs and configurations and things like that. So for instance, in the free version, you have policies. Now the policies are saying here are things you apply out to your resources, saying here's what I want for security, and all this the free one gives you back is recommendations. Here's what we would recommend you do. It's not going to enforce anything or anything. It's just going to say here's what I'm recommending. It will give you a general security score. You're doing pretty well. You're not doing pretty well, et cetera. And there'll be some recommendations that you can look in. So that's what the free gives you in a nutshell. When you move to the fee version, which is per workload, not only am I going to give you recommendations, I will now identify the weaknesses in your configuration. I'll tell you what I'm seeing is wrong in it. It will tell you my security posture. Like, for instance, do my data stores contain sensitive data? You have a bunch of storage accounts out there. Which contains sensitive data, which doesn't? Well, this one will tell you. This one has sensitive data in it. If you want to make some security changes, for fee one will now let you model the traffic for your change and let you know what the potential risks are if you implement that change. Here's where you're opening a door, type of thing. So, and it gives you more of that information with permissions and governance and other things like that. So that's what the for fee does. And again, it's for fee per workload. So you would get this for virtual machines, you would get this for storage, et cetera, et cetera. But this now not only gives you general information, you still get the general information, but you're going to also get detailed information about your stuff, and it will let you know where the weaknesses are. Instead of just like, here's some general recommendations. Oh, by the way, I see that you don't have X turned on. That would just be a general recommendation that everybody should probably have that on. Whereas here will tell you where that lack of feature and being enabled, where it's causing you real weaknesses in your environment. So it's worth the money to get visibility into your world, because sometimes you're just going to get a report like this, which is you get out of the basic one, and you're going to go, oh, my Azure is 55%. I don't know what that means. It can give you general recommendations. Maybe you should, you enable MFA, secure management ports, remediate vulnerabilities. Where are they in my environment? Well, the for fee one will tell you where these are and how to remediate them, et cetera, as opposed to just these general recommendations. If you've ever been into Office 365 and looked at Secure Score, well, that's what this is. This is Secure Score in the Azure world for those resources. It will give you information about alerts that you can drill into. So you can with it for fee one, by the way, I can see that I'm having some security issues. I can click on one and get information about it. When did it happen? What was attacked? What was the command line used? What user ID was used on it, et cetera. So now I have some information about what happened here and what other related entities may have been affected by this. So I get some information about what's happening in my environment and some traceable things. All right. So Azure Monitor. This is a way to collect your logs together. Now, what Azure Monitor is it's a way of collecting your logs collated from all these different resources. So application logs, operating system logs, Azure resource logs, et cetera. And a lot of these logs have different formats to them, different structures of how the log file is. But Azure Monitor understands that and can handle those multiple different logs and collates all these things to give you both metrics on what it's seeing out there and a view into the logs. And then from that information, you can build through queries. You can gain insights from maybe metrics. You can build dashboards from queries that you're getting in these logs. You can build a dashboard that is constantly going to monitor, going to be running a particular set of queries or whatever you posted up on your dashboard, so that you can see the data that you think you need to see on a regular basis here. So you can, how you're dealing with alerts and how you're integrating with apps. So this integration with logic apps is a process, so that I recognize something and maybe I see something in the analytics. I'm going to generate alert. I'm going to automatically do something about it. I'm going to send an email to this person. I'm going to do this action, et cetera. So we can integrate it with logic apps and take some automated actions on this. So again, it's basically a very robust logging tool that pulls from multiple sources and then lets you use this data to build things, processes, notifications, dashboards, things like that. So you know what your world is like. Of course, and again, we're looking into an Azure Monitor screen here, and of course you get your metrics that you see here, but you also get your logs. Now, the logs can be queried. You're not going to get a raw look at the logs. What you do is you query them, and then you write your query down into this area here and run it, and it provides you back information about your whatever it was you queried. You can save that query, build that query, or pull that query into a logic app and do something with it, or save that query and put it as part of a dashboard so that it's constantly running and showing you some piece of information about your environment. So the Azure Monitor gives you visibility. Defender for Cloud gives you Microsoft's view of the world and things like that. Azure Monitor is something under your control to give you the information you want, to take the actions you want on that. So those are ways to manage and see what's happening in your infrastructure. So what did we talk about today? Well, we talked about VNets and subnets. That's where your IP address ranges and you're segmenting out into subnets where your devices would live. We mentioned that hub and spoke is the recommended design for centralizing external access into one VNet and then let it feed out from there. We talked about using VNet peering and route tables to control traffic between your multiple VNets. So VNet peering just opens the channel, and route tables lock it down to the specific endpoints that you want it to be. We talked about network security groups and how you can filter to subnets and NICs and how they build on each other, first processing a subnet NSG and then a NIC NSG. So you can get some pretty granular access control list filtering. We talked about bastion hosts to take away the RDP access to your servers from the public IP address. And now you're doing a secure 443 connection to manage your servers. VPN gateways for site-to-site and point-to-site connections in your environment. We talked about the Azure Firewall, both the standard and the premium edition, and that the premium gives you things like TLS inspection and intrusion protection and web categories, et cetera, et cetera. We talked about endpoints, private endpoints, and service endpoints, keeping your traffic on the Microsoft network. Private endpoints will use a private IP address. Service endpoints still use the public IP address, but keeps it on the network. I mean, there was a table there to choose which one is proper for your particular application. Remote role-based access control. Least privilege access, that's what you want to be thinking. Think about what roles people absolutely need and only assign those roles to the smallest scope required to do their job. Defender for Cloud is a free and a for-fee product that gives you a detailed knowledge of your security posture. It gives you either recommendations or identifies weaknesses, depending on which plan you're in, and lets you know where you're standing with your security. And Azure Monitor is a way of you looking at your logs without having to call through the text of them. You can build them into dashboards and other reports that make more sense and give you that information quickly so you can move about your day. So that's what we're going to use to and there's more. Yeah, again, I have to pick and choose what I'm going to be putting into this environment, into this webinar. That talks about what's on your environment and how to secure it and how to know what's on your environment and if it's actually working the way it's supposed to be. And that brings us to the end. So, Chris, I'm going to hand this back to you to talk about next steps.
Thank you, Dave. We appreciate lots of great information in there. So this slide, of course, will be in the deck that you'll receive later on this afternoon, but several Azure-related courses with some discounted pricing available. So if one of those are of interest, you can check that out through our training department. We are right up against 1 o'clock, so I don't want to start a question here that we may not be able to give proper information for, but we will reach out to the person who submitted the question directly to answer that for you. Once again, thanks so much to Dave. Thanks so much to each of you, and I hope you have a great rest of the afternoon. Thank you so much.